Hello dear students, in the previous videos you have seen properties of Laplace transform, and using the properties of Laplace transforms we have solved the examples. Okay, that is first property. If L of f of t is equals to f bar of s, then L of e raised to at into f of t. Means a function like e raised to at into f of t, then the Laplace transform of this term is nothing but f bar of s minus a. Next, if L of f of t is equals to f bar of s, then if a function like t raised to n f of t, then Laplace transform of t raised to n f of t is minus 1 raised to n d raised to n upon ds raised to n into f bar of s. Okay, using these two properties we have solved example problems in the previous videos. Let us go for the third property. If L of f of t is equals to f bar of s, then L of f of t by t, that is equals to integration s to infinity f bar of s ds. Using this third property, let us solve the exam problems here. Find Laplace transform of 1 minus e raised to minus at upon t. Okay, this is a given function. The given function is like f of t by t. Okay, for this one we need to use third property. Okay. Let us find Laplace transform of f of t first. Let f of t is equals to 1 minus e raised to minus at. Next, f bar of s is nothing but Laplace transform of f of t. That is Laplace transform of 1, Laplace transform of e raised to minus at. Laplace transform of 1 is 1 by s. And Laplace transform of e raised to minus at is minus 1 upon s plus a. This is nothing but 1 upon s minus of minus a, nothing but 1 upon s plus a. Next, we need to find Laplace transform of a given function. We know we have a third property. L of f of t by t is equals to integration s to infinity f bar of s into ds. That is Laplace transform of a function 1 minus e raised to minus at upon t is integration s to infinity 1 by s minus 1 upon s plus a into ds. Means differentiating this f bar of s with respect to s between the limits s to infinity. Integration of 1 by s log s minus integration of 1 upon s plus a is log s plus a between the limits s to infinity. Now it looks like log a minus log b. Log a minus log b is nothing but second law of logarithm log of a by b. Using this one we are writing this step as log of s upon s plus a limits s to infinity. Next, here I want to apply the limits s equals to infinity, s equals to s. Limit s tending to infinity log of s upon s plus a minus, here already substituted the limit s as s, therefore it is log of s upon s plus a. Next, here I want to substitute s tending to infinity. Okay, to put an infinite limit, let me simplify this term first. If you directly put limit infinity here we are getting the infinite terms. Therefore, I am just making some simplification here. In the denominator, I am just taking s common from these terms. Taking s common from these terms, we obtain limit s tending to infinity log of s upon s into bracket 1 plus a by s. S cancels here. Minus log of s upon s plus a. Again, in the first term, left term is limit s tending to infinity log of 1 upon 1 plus a by s. Right? Now putting the limit s as infinity, log of 1 upon 1 plus a by infinity minus log of s upon s plus a. Okay, a by infinity is 0. Log of 1 upon 1 plus 0, that is log 1. Log 1 minus log of s upon s plus a. Now again using the recurring law, this we are writing it as log of 1 upon s upon s plus a, or this becomes s plus a goes to the numerator. We have obtained the Laplace transform of 1 minus e raised to minus at upon t is log of s plus a upon s. Okay, let us go for the next example. Next problem. Find Laplace transform of cos at minus cos bt upon t. Cos at minus cos bt upon t. Now it is also like f of t by t. let us consider f of t term here. Let f of t is equals to cos at minus cos bt. Next we need to find Laplace transform of this term, that is L of f of t is equals to L of cos at minus L of cos bt, that is Laplace transform of cos at, Laplace transform of cos bt. That is L of f of t is nothing but f bar of s, that is equals to L of f of t is equals to Laplace transform of cos at is s upon s square plus a square. Laplace transform of cos bt is s upon s square plus b square. Okay, this is nothing but our f bar of s. Next we need f bar of s is nothing but Laplace transform of a f of t. Now the given function is in the form of f of t by t. Therefore L of f of t by t is equals to integration s to infinity s upon s square plus a square minus s upon s square plus b square. That means here we are integrating f bar of s term, that is f bar of s is nothing but s upon s square plus a square minus s upon s square plus b square. We are integrating this term with respect to s between the limits s to infinity. That is L of cos at minus cos bt upon t, that is equals to 1 by 2 into log of s square plus a square minus log of s square plus b square. Integration of s upon s square plus a square is 1 by 2 log of s square plus a square minus 1 by 2 log of s square plus b square. Taking 1 by 2 outside means common, we have obtained 1 by 2 into bracket log of s square plus a square minus log of s square plus b square between the limits s to infinity. Next, this is again like log a minus log b. We are writing it as log a by b, that is log of s square plus a square upon s square plus b square between the limits s to infinity. Next I want to put the limit, upper limit infinity, lower limit s, that is 1 by 2 into bracket limit s tends to infinity log of, here I want to put the limit infinity, therefore I am taking s square common from this term, s square common from this term, that is s square into bracket 1 plus a square by s square upon s square into bracket 1 plus b square by s square minus log of s square plus a square upon s square plus b square. Second limit already s equals to s. S square x square get cancelled here, that is 1 by 2 into bracket limit s tends to infinity log of 1 plus a square by s square upon 1 plus b square by s square minus log of s square plus a square upon s square plus b square. Next substituting the limit s as infinity here, that is a square by infinity, b square by infinity. A square by infinity is 0, b square by infinity also 0. 1 plus 0 upon 1 plus 0 is nothing but 1 only. Therefore here this step we have obtained log 1 minus log of s square plus a square upon s square plus b square. Next again using law of logarithm, this we can write it as log of s square plus b square upon s square plus a square, that is 1 by 2 into log of s square plus b square upon s square plus a square. Now this term is like m log k. M log k you can write it as log k raised to m, that is log of s square plus b square upon s square plus a square whole raised to 1 by 2. Therefore Laplace transform of a given function cos at minus cos bt upon t is log of s square plus b square upon s square plus a square whole raised to 1 by 2. Okay, let's go for next problem. Find Laplace transform of 2 sin t sin 5t upon t. 2 sin t sin 5t upon t. Let f of t is equals to 2 sin t sin 5t. Let f of t is equals to 2 sin t sin 5t, because this is of the form f of t by t. Next, this for sin t into sin 5t, I am applying the trigonometric formula sin a into sin b is equals to 1 by 2 into bracket cos of a minus b minus cos of a plus b. Sin a into sin b is equals to minus 1 by 2 into bracket cos of a minus b minus cos of a plus b. Or multiplying minus inside, we are getting it is minus 1 by 2 cos of a minus b minus cos of a plus b. That is 2 into 1 by 2 into bracket cos of minus 4t minus of cos 6t. That is t minus 5t minus 4t t plus 5t cos 6t. 2 get cancels here. Cos of minus theta is cos theta, that is cos 4t minus cos 6t. F of t, whatever f of t is here, we have rewritten this in the form like this, because for this one it is somewhat difficult to apply Laplace transform for this term, given term. Therefore now we have obtained the new function like this. F of t is equals to cos 4t minus cos 6t. Next, let us find f bar of s. Nothing but Laplace transform of this term. F bar of s is equals to L of f of t, that is equals to s upon s square plus 60 minus s upon s square plus 36. That is Laplace transform of cos at, that is a upon s square plus a square. Here a is 4, a is 6. S upon s square plus 60 minus s upon s square plus 36. Now it is of the form f of t by t. Therefore we need to integrate this term between the limits s and infinity. We need to integrate with respect to s. That is integration of s upon s square plus 16 is 1 by 2 into log of s square plus 16. Integration of s upon s square plus 36 is 1 by 2 into log of s square plus 36. Taking 1 by 2 common from the term, directly I have written it as 1 by 2 log of s square plus 16 minus log of s square plus 36. Or let me write once again. That is 1 by 2 log of s square plus 16 minus 1 by 2 log of s square plus 36. S square plus 36 between the limits s to infinity. Next, taking 1 by 2 common from the terms, that is 1 by 2 into bracket log of s square plus 16 minus log of s square plus 36. Next, Laplace transform of 2 sin t sin 5t upon t is equals to 1 by 2 into bracket log of s square plus 16 upon s square plus 36. Means here applied the law of logarithm between the limits s to infinity. Next, we are applying the limits infinity and s. Limit tending to infinity, that is 1 by 2 log of taking s square common from these two terms, because here we are applying infinite limits. S square into bracket 1 plus 16 by s square upon s square into bracket 1 plus 36 by s square minus 1 by 2 into, already here s tends to s applied. Therefore 1 by 2 into log of s square plus 16 upon s square plus 36. Next, take 1 by 2 outside. Here s square get cancelled. 16 by s square means infinite limit. 16 by infinity, 36 by infinity. These two terms become 0. Here the left with the first term is log 1 minus log of s square plus 16 upon s square plus 36. Simplifying this bracket term, we have obtained 1 by 2 into log of s square plus 36 upon s square plus 16. Next, again applying law of logarithm, here we obtain log of square root s square plus 36 upon s square plus 16.